All right, guys, welcome. Here's a brief tutorial, a little bit of information on scientific measurement, and it'll be a little bit shaky, but the perspective is not me, it's the information. All right, in this particular item on scientific measurement, there's an idea of unit versus type. Well, type means what kind of measurement are you taking? Well, we're going to concentrate on really the first six, much more so than 7 and 8, but length, volume, mass, weight, time, temperature, energy, and density. Don't put a lot of worry into this right now. We will discuss units a little bit more fully. That was just simply to get your attention. So of these measurement types, we learn that there are different units. Now, we know that the circled unit is called the base unit, but these other units are used to really to quantify. Let's take, for instance, length. If I were going to tell you your height, then, perhaps centimeters, probably more so meters would be the correct unit. But if I'm going to go on a cross-country trip across the nation, obviously, I'm going to use kilometers. If I'm going to buy milk, I'm going to talk about liters. If I'm going to talk about smaller amounts, I'm going to talk about milliliters. So the unit will be respective to really the amount that we are using or the amount that we have. Part of the main point you should take right now is these are metric system or SI units, which are universally accepted scientifically worldwide. Okay? All right, and you might also make a quick note, as we've mentioned, that density has more than one unit because it's a calculation. So in this unit, do I want to talk about measurement? Yes. Do I want to talk about types of measurement? Yes. Do I want to talk about units? Yes. Each one of these tools that you might use to do some of these calculations or measurements, rather, I would say measurements rather than calculations, are probably going to have a scale, and the scale will be relatively easy to figure out. You just need to take what I call the span divided by the number of lines. So if you have a span of 4 and you have 1, 2, 3, 4 lines, that should be pretty simple. 1, 2, 3, 4. If you have 4 lines, then in this particular case, whatever that is, it would have it would be equal to 1. Each line would be 1. So that's pretty straightforward. The last thing in this unit, or in this particular topic, rather, of study, it gives us a chance to kind of talk about sig figs, or significant figures, but really in a more practical way, as the significant figures will be strictly related to the precision of the instrument that you are using. Okay, let's go take a look at some of the instruments. Okay, so here's a quick look at some of the instruments, and some of them are really pretty simple, guys. Like, for instance, you've got your meter stick, you've got a Newton scale. Here's just a simple ruler, and when you look at the ruler, you can see that it measures in millimeters and centimeters. Here's a triple beam balance. Here's a thermometer, something simple like a stopwatch, a beaker, graduated cylinders, okay? Now, very quickly, what would we have represented? Well, we could have length. We would definitely have mass. Here we would have temperature. Here we would have time. Obviously, this would be representative of volume. And here we would have mass. Now, my point is not that these are the only tools. My point is these are some of the simple tools that we could use. Now, here's a couple of classic examples of how to calculate scale. So right here on the Newton scale, you can see that we go from 0 to 4, and if you count the number of lines, you will see that there are 8 lines. Well, then that's pretty simple math. We're going to have 4 divided by 8, so the most precise that this particular instrument could be would be 0.5 of a Newton, capital N. Now, what about this one right here? Well, if you look at this particular ruler and you look between the 1 and the 2, if you counted the lines, there would be 10 lines. That's a span of 1 divided by 10, so the scale would have to be 0.1. So that would be to the 10th place. So something like 1.1, 1.5, 1.9, that would be as precise as we would be able to be with this particular instrument, which would help us determine our significant figures. Here, we have a triple beam balance, and you'll notice that the middle beam is increments of 100, the top beam is increments of 10, and once again, we have the same overall scale. Maybe that's one of the reasons why they often talk about the metric system being based on multiples of 10. What about our thermometer? Our thermometer also finds itself in the same category. When you go from 10 to 20, but in between 10 to 20, you have 10 little lines. So you have a span of 10 divided by 10, which means that your unit, not unit, but your measurement there would be 1. Here, we have a graduated cylinder, which is also illustrating a distance of 10, but 10 little lines, so each line would be 1 milliliter. Now, how do I know that? Well, I know that because what does this say right here? It very plainly says milliliters. Now, this is a graduated cylinder because of the graduations. Each of these little lines are referred to as graduations. Now, what do I have here? Well, I have a beaker, but here's the problem with the beaker. It's really not all that precise. From 300 to 400, you only have one line. So you have a span of 100, but you only have 2 lines. That means that's got to be a 50. What if you fall in between? Well, if you fall in between, we just would have to guess, and that's not going to work. So that is not a very precise tool for measuring volume. All right, now here is a meter stick, which actually goes from 1 centimeter all the way to 100. And obviously, you could measure length. And once again, however, what would you find? You find the same scale that you find here. Okay? All right, now, very quickly, a quick item on the triple beam. You do not put in between notches. The weights have to fit solidly in a notch. There is no guessing. Guys, the purpose of a tool is not to guess. The purpose of a tool is to be as precise as that tool will allow you to be. These are not super duper precise tools, okay? They give us, honestly, fairly rough measurements, but they do enable us to talk about metric system. They enable us to talk about metric system units. For instance, grams, milliliters, minutes, seconds, degrees Celsius, centimeters or millimeters, weight in newtons, meters, centimeters or millimeters. So we get a chance to talk about measurement types. We get a chance to talk a little bit about units. We get a chance to calculate scale, which is simply span divided by the number of lines. And then we have the opportunity to begin talking about sig figs, understanding that sig figs will be based on the precision level of the tool that we are using. So let's take a look at this tool. All right, so if I hang this weight, and obviously this is weight because gravity is pulling down, and in the interest of making this as simple as we can, we're going to say that this particular item is, and I'm looking through my phone here, but we're going to say that let's just say it's 4 and 2 little lines. Well, we know that each one of those lines is 0.5. So if that were the case, this measurement would be 5 newtons. Now, if it were directly on the line to where it was exactly 5, then how would we write that measurement if we also wanted to consider significant figures? Well, we would write 5.0 newtons. Why? Because this is as precise as that instrument will allow us to be. Now, let's take a quick look at Mr. Day's stopwatch. You will notice that you have minutes and you have seconds, but look at that double zero up above. What could that possibly be? Well, this particular watch could measure to 1/100th of a second. All right, now that's moving pretty quickly, and I understand that, so let's pause it. So the question is, what is my measurement? The measurement is 13.34 seconds because I have not yet touched the minute. Now, how would I write this? Thinking about sig figs. I would write it as 13.34 seconds because that is the number of sig figs related to the precision level of what? Of this. That's as precise as I can be. Now, one last item or two before we conclude. When I read the water level in something, especially something like a graduated cylinder, I will always notice as I look at it from the side that the water always appears to have a curve to it. That curve is called the meniscus, and I read from the lower portion of that meniscus. Okay, closing comments. Closing comments are very simple. Each one of these tools has a measurement type. Each of the types has units, in many cases more than one unit, related to the quantity or size of the item that you are measuring. Each one also will have a certain level of precision. That will have a direct impact on your significant figures. Every one of these measures in the metric system, or the SI unit of measurement. Once again, we have weight, we have length, we have mass, we have temperature, we have time, we have volume. All of these items are represented with these tools.